This is an introduction to pipe stress analysis and why it is carried out. The most important reason pipe stress analysis is carried out is safety.
Hello students, welcome to the introductory session of pipe stress analysis. I am Manjunath. I have several years of experience working as a pipe stress engineer. Let's start this session. Pipe stress analysis is the integral part of piping engineering. To understand pipe stress analysis, we must have knowledge of piping system and its design. Piping system is mixture of pipe, fittings and all its auxiliaries and components. Let's understand what is piping system is. Piping system and its design. While designing a refinery, petrochemical complex, power plant, aluminum smelter, etc., piping is very similar to arteries and veins in human body, interconnecting all small and big equipments. Any piping failure can cause unmanageable catastrophe, resulting in not only the loss of plant or machinery but also human life. Pipes are most delicate component in any process plant. They are also the most busy entities. They are subjected to almost all kinds of load, intentional or unintentional. It is very important to take notes of all potential loads that piping system would encounter during its operation as well as during the other stages in the life of process plant. Ignoring any such loads while designing, erecting, hydro-testing, startup, shutdown, normal operation, maintenance, etc. can lead inadequate design and engineering of piping system may fail on first occurrence of overlooked load. Failure of piping systems may trigger domino effect and cause a major disaster. Let's have a look on the plant piping. In this diagram we can see the sulfuric acid plant model with the all piping arrangement. It shows the equipments connected to the pipes and equipment building and surrounding piping. This is diagram showing the presentation of chemical equipment plant where the chemical equipments are connected by the piping. This is the PDS representation of chemical process plant. Here we can see the live picture from tank farm area where the equipments are connected by the piping. So we can understand how piping is important to connect the different equipments in the process industries. Let's have a look of the beverage industries where piping is connecting to the different equipments. This all the yellow lines, they carries the fluid, process fluid to the different equipments. We can have a feel by seeing this picture how the piping is important as a subject of study. This is very good picture of piping. We can see here the various different equipments connected by pipes. We can see the CDU unit as well. We can see the air cooler system as well on the top of the pipe rack. We can see the different heat exchangers. They are connected by the pipes, and pipes is moving. So big picture of all the pipes connections we can see here. To understand the piping system, we need to understand the behavior of the piping system. We need to do the behavior study under different potential loading conditions, such as primary versus secondary, sustained versus occasional, static versus dynamic. Under different all possible potential loadings, the piping system behave differently. The piping system and their implications on the stresses that will be generated in pipes are need to be minimized under the given code guidelines. To minimize the effect of such loads and keep resultant stress under the limit specified by the codes, we need to follow some code guidelines. Final design and engineering of piping system may have to go through the rigorous calculations. The rigorous calculation may be a manual or computer. Collective information of all such loads and sound analytical skill is required to take engineering decision and to mitigate this effect. Regulatory requirements are given under some codes that we need to follow. Such codes are ASME B31.1 for power plants and 31.3 for refineries and petrochemicals. We'll see in details about these codes and their guidelines in details in our next session.